kilograms. 400 newtons. Okay. And no net force. So now the magnitude is going to the right. So the magnitude of F is just what was given. 400 newtons. Easy. Okay, part B. What is the acceleration of the refrigerator 4 seconds after the person begins pushing on it with a force of 400 newtons? Let's see. Okay. So we have acceleration given by A, just acceleration, and we want to know, so we have 400 newtons, okay, and the force was 200, wait, the weight is 200 kilograms. So we have, okay, so we have F net, okay, F net is simply equal to mass times acceleration, okay, so if F net equals mass acceleration, we want to know what A is, so we need to take this and we need to substitute for A. So A is just going to be F of net divided by the M. We can further work with this problem and say A equals force, or F net is just 400 newtons. It was given in the problem. So 400 divided by the mass. It's 200. We know this is kilograms and this is newtons. This results in 2 millimeters per second squared, which is equal to A. And that is the acceleration. For part B. Part C. Let's see what we have. So for part C, we are, over here. So he says, adjust the mass of the refrigerator by stacking different objects on top of it. Alright, it is increased with applied force have constant. What happens to the acceleration? Okay, so if the mass of the refrigerator is increased, so if we look at this formula, if mass is increased, right, what happens to acceleration? Well, we flipped it over here. When mass goes up and the force remains the same, then the A has to decrease. So acceleration decreases when MAM goes up. All right. Part D. Okay, let's see. we're using 50 crate. Hold on, I can barely see that. Okay. We're in D. Okay, so 50 kilograms and 100 newtons. Release center is now in the figure system. What happens to the crate after the applied force goes to 0? So you have a crate and you have a force, right? Have a force that's pushing it. So we have a force, right? To the right. And then this causes the this causes what? So we have force given to a 50, right? Hold on. So we have A equals, because we know what happens to acceleration. So we have force F net divided by man, right? Okay. So if we have that, and we have a force to the right, this means we have a given force, 450, and that means we'll have an acceleration. But then when this goes to 0, right, when F net goes to 0, A also goes to 0. So no acceleration, but velocity remains constant. So V is constant. Okay, that's what happens. Now we're going to move on to part E. All right. So we have a refrigerator this time. Okay, and what we need to know is we're going to apply 400 newtons of force to an object. After 2 seconds, decrease the net force slowly back to 0. When applied force is decreasing, the velocity is, well, let's think about this. So, the velocity, right? Your velocity depends on your acceleration. So when a force, right, when the force is applied to the right, right, when there's an F force applied to the right, approaches 0, right? V will, A will approach 0. Right? Which we said before. And as this happens in 2 seconds, V velocity will increase slowly, slower, right? Until it no longer increases. It no longer increases. All right. So that means it's increasing. Okay. We go down to the next problem. Let's see. We have. All right. 50 crates, one on top of each other, that means to make 100 kilogram total weight of the object. All right, and then we're gonna have some friction. Okay, we're gonna have a little bit of friction going on. Forces sort of slowly and determine when the crate begins accelerating. What is the minimum force that must be exerted on the crates so that they accelerate, right? Okay. So we have 100 kilogram and the friction, okay? The friction force, okay, by playing this video. Right? Friction. So we have two crates, right? And we want to know how much force we need to apply in order to get it moving. So let's see. All right. So we have friction working against us. And just like that, the sum of forces is positive. Right at 250 for friction. So, I'm going to turn here. So now, where were we? We were in F. So 250 is the answer. Yeah, roughly. So, 250 Newton equals friction. Okay. And now, we'll go to the next problem. Let's see. If the total force is 350, the acceleration is, okay, so that's easy. So if force equals 350 Newton, and then friction equals, what was it, 250? Negative direction because it works backwards. Well, this minus that is the net force. F net is just 350 minus 250, right? So F net is 100 Newton. The weight, right? Weight equals 100 kilogram. And what we want to know, the acceleration. So we're now force equals mass times acceleration, and acceleration equals force divided by mass. So we have acceleration equals 100 Newton divided by 100 kilogram. So that's just 1. So A equals 1, right? Meter second squared. Acceleration. Okay. We still have one more problem left. And now, after 3 seconds, right? After 3 seconds of applying this force, we're just gonna take the force out. So that means the friction force, this is pretty simple, the friction force, so part H. So F equals 350 Newton for 3 seconds. per 3 seconds, right? Then F equals 0. So you have friction. Friction equals negative 250 Newton. Okay? So A is gonna negative. And then slows down. Right? Easy. Okay, that's the end.